Hi everyone, I'm Judith Pereira from the University of Auckland. My supervisors are Evan and Kelly. So let's add a picture to the story that I was talking about in the morning. So you're familiar with building a house or owning a house, and you might have seen developers building a house. So what if they don't do things properly? What if the foundation is not built properly, the walls are not built properly? And then in the end, when you try to add a new window, it becomes difficult if things are not done properly. So this concept is similar in software development. We call it technical debt, this phenomenon. And if software developers do not build software according to the optimal development path, and if they do quick fixes and take shortcuts instead to gain a benefit in the short term, although you gain a benefit in the short term, in the long term, the software quality degrades and then it becomes difficult to add new features. So let's take an example, everyday software, map software, Google Maps or iMaps, anything which you like. So let's say these are the top 4 features. Let's say we own a software company, and just going back to that slide. Let's say these are the top 4 features. So searching a location, saving a location, getting directions to go from one place to another, and monitoring real-time traffic. So let's say we have a software company and we develop these features. Everything goes according to plan, and we deliver the product on time to market. Let's say that a competitive company develops a similar software, and now we want to gain competitive advantage delivering our product early to market. So what we do is we develop feature 1, and then we take a shortcut to develop feature 2. So here we're introducing technical debt while we develop feature 2. So for example, maybe in terms of code smells, design smells, or architectural smells. And then even though we gain a benefit in the short term, in the long term it becomes difficult to add feature 3 and feature 4, causing extra work that needs to be done prior to the development of the feature. So it could take longer and even longer to deliver these features. Let's say we take a different development path now. So we implement feature 1, implement feature 2 taking a shortcut, but then we decide to refactor. So remove the technical debt that we introduced in the previous step. So then we make it on time to deliver feature 3 and feature 4. So this is an example where we took technical debt as a strategy to deliver the product on time to market, but still kept on track with the product development and didn't let the software quality degrade in the long run. So yeah, you know now that technical debt captures the consequences of making suboptimal design decisions. So making suboptimal design decisions can be beneficial in the short term, but can be detrimental in the long run as the quality of the product degrades and then it becomes difficult to add new features. So TD must be managed. For TD to be managed effectively, we need to quantify it. So which means answering questions such as how much time it will take to develop a software, and then how much time I will save in software term, in short term if I take on TD. Can I keep on taking TD? Do I need to refactor now, or can I refactor later? Will I gain a benefit by taking TD now or refactoring now? So my PhD research tackles this problem by looking at how TD can be quantified, or how we can model the quantification of TD to help make informed decisions for technical debt management. So these are the research questions that I'm trying to answer. So I would say that the first three research questions have been answered, and RQ4 and RQ5 are future work. So in RQ1, we looked at what are the existing proposals to TD quantification. And then with RQ2, we looked at how can we model TD quantification. And then in RQ3, we applied the model that we developed to the existing approaches to do comparisons between them. And for future work, I'm looking at part of the model with RQ4. So kind of looking at what's the relationship between TD items, new code, and rework. So this was derivation from the model. And RQ5 addresses a limitation of the model, looking at how we can quantify non-code related types of TD such as requirements debt, because the model was initially developed for software code related TD types, which are code TD, design TD, and architectural TD. So RQ1, so I'm not presenting a lot of results of the mapping study, but just to mention that the systematic mapping study, through that we explored that there were multiple quantification approaches, but they did not have consensus among them. So they were focusing on different aspects of TD. Some of them were identifying, for example, code smells, design smells, and architectural smells, and then the quantification was based on those. And some approaches, they were quantifying return on investment for refactoring, while some approaches compare an ideal state with the current state of the software in terms of software quality, and then some approaches compare alternative development paths to reduce TD. So it was unclear if all these approaches are quantifying the same thing and if they supported similar or different decisions regarding technical debt management. So it was clear that there was a problem not being able to effectively compare and evaluate these approaches, which became the motivation for RQ2 and the motivation to develop a common model that serves as a reference point to efficiently compare and evaluate quantification approaches, and also to be able to develop new quantification approaches based on the common model. So the Technical Debt Quantification Model, TDQM, was the result. And we have a conceptual model, approach comparison matrix, calculation model, and a decision model as part of this. So the conceptual model captures important concepts related to TD quantification and identifies the relationships between them. The approach comparison matrix provides a systematic way to compare and evaluate different quantification approaches. The calculation model illustrates how the total cost of development path and the TD interest can be calculated. And the decision model identifies the concepts that could be used for decision making and then maps decision making context, questions, and concepts. So this is the model, the conceptual model. And the concepts in this was derived based on existing literature and then put together. So the concepts are categorized to process-related, cost-related, benefit, and probability-related concepts. So a product consists of one or multiple releases created through one or multiple development paths. A development path consists of one to many development steps, which can be either an implementation step or a refactoring step. And an implementation step usually introduces a feature, but could also introduce a TD item. And a refactoring step eliminates a TD item. A development path can have a total cost of development path, and a development step has a total cost of development step, which constitutes of the implementation cost of the feature and TD interest if TD was introduced in previous development step. And then refactoring step has a cost of refactoring. And then the implementation cost of a feature and TD interest can be further broken down into new code cost and rework cost. Then we also say that refactoring can have a benefit, which is long-term, and taking TD also can have a benefit, which is short-term, as discussed in the previous example. Then interest probability determines if a technical debt item actually affects future development. So if it's affecting, then the interest probability is 1. So back to the example, and the model concepts have been used here to annotate the example. As you can see, the scenario can be described with the TDQM concepts. So this is the approach comparison matrix. This is the legend. We have 21 concepts in TDQM. So they have been put down as columns, categorized into process, cost, benefit, and probability-related concepts. And here we tried to map 2 existing quantification approaches, which are popular nodes and Casman's approach. So the mapping you can see here, the model concepts So the approach concepts are on the left, and on the right are the model concepts, the mapping to the model concepts. So this is Caseman's approach concepts, and then the mapping. And we have different levels of mappings: direct, associated, contributes, and the combined mapping is a simplification of the detailed mappings. And this is how you can use this matrix to identify similarities and differences between the different quantification approaches. This is, so previously you saw the detailed view of the matrix, and this is the compact view. So here we used the model to compare 39 approaches, and this is the two previously described approaches you see highlighted here. So you can see that the matrix allows efficient comparison between all the approaches together at the same time. So RQ3, how can we assess quantification approaches using TDQM? So here we did a study applying the matrix, the conceptual model and the approach comparison matrix with 39 approaches, 33 approaches that we identified through the first iteration of the mapping study prior to the development of the model. And then we extended the mapping study to recent studies from 2020 to 22, identified 6 more approaches, and then also applied the model to those approaches. And it was validating the model theoretically. So this is an example how we can use the model to identify approaches quantifying the same TDQM concept. So this is TD item, TD interest, and refactoring cost. So this also shows the contribution of TDQM, that it systematically compares and evaluates quantification approaches. So here, this is another classification that we did, and we figured out that architecture debt was the TD type that covered most of the TDQM concepts. And we also were able to do some ranking, and we ranked these within the TD types. So from 1 to 3, these are the top 3 approaches covering 19, 14, and 13 concepts of TDQM respectively. So here, the TDQM contribution is being able to determine how much an approach comprehends TD quantification based on the coverage of TDQM concepts. So this is another visualization or classification, I would say, which allowed us to identify trends. So 2012, 15, and 16 were the years where TD quantification was mostly discussed. So this is the calculation model. And going back to the example, I'm mapping it to the calculation model. We have done some simplifying assumptions here for the calculation model. This is the perfect path if everything goes finely. And then let's say you decide to take TD. So branching up, you develop without taking TD. So branching down, you might decide to take a TD item. So here for feature 2, you took a TD item, and then that's the development path. And if you decide to refactor, so you eliminate a TD item, and then that would be the total cost. So yeah, this is simulating the total cost, and we could also do it for TD interest similarly. So this calculation model is theoretical at the moment, but it's open for researchers to extend it. And this is the decision model. We mapped decision-making context to decision-making questions, and then the TDQM concepts that help answer these TDM decisions. So this is an example decision-making question. What alternative development paths could we take to reduce overall accumulation of TD interest? So in this case, the TDQM concepts, the total cost of development path, and TD interest can be helpful. So that mapping helps you make that decision. So here the contribution is determining the usefulness of a quantification approach using TDQM in decision making. So these are the 2 approaches that I discussed before were again mapped to this model as well. So it shows that these 2 approaches help you make different decisions in the 3 different contexts. And yeah, So this is a summarization of the contributions of TDQM. It provides a systematic way to compare and evaluate quantification approaches, and then also allows you classify and visualize trends regarding quantification approaches, and then facilitates assessing quantification approaches based on the TDQM concepts, which means it allows you see how much TD quantification approach comprehends TD quantification, and then also determine the usefulness of an approach in TDM decision making. And additionally, TDQM also serves as a reference point to develop new quantification approaches. So the current limitation we see with TDQM is that it was developed for software code-related TD types, which means code, design, and architectural TD, and we haven't addressed other TD types such as requirements or test or documentation yet. So our future work will be addressing this, and this is one of the future work. So this is RQ 4, which is addressing part of the model, actually looking at the relationship between TD item and TD interest based on the constituents new code cost and rework cost. So we will be experimenting with open source software for this. So it would also validate this part of the model. And as addressing the limitations with regards to what TD types can be quantified. So to address the part where we look at the quantification of non-code related TD types, we selected requirements did as it can be connected with features, which is an existing concept in the model. And we work with a case study in New Zealand. So looking at requirements, elicitation, and how they go into development with software developed for the New Zealand organic product supply chain. So we will look at requirements, elicitation, and then how the requirements go into the SRS, and then how it goes into feature development, and how TD can be introduced in these steps. And so the definition I'm using here for requirements that is suboptimally implemented requirements, which means partially incorrectly or non-implemented requirements. But this is at the moment an initial definition, so we'll see how it will be defined in the future. So yeah, this is the summary, completed work, the mapping study, the development of the model, and then the application of the model to existing quantification approaches. And the future work is the experiment with TD items, new code, and rework to find the relationship between them, and then extending TDQM to non-code related TD types. Thank you.
So I like this work a lot, and I've always thought that the concept of technical debt, when Ward Cunningham articulated it, was a really useful idea. But I'm a bit puzzled about something. Can you go back to the flowchart kind of picture? Yeah, this. So the benefit of taking TD there, why do you call that a short-term benefit?
That's because you take on TD to gain a short-term benefit, like gaining competitive advantage.
Why do you call that short-term?
Compared to the other one, the other benefit that you get by refactoring, because that's more long-term with regards to software quality, I would say.
Well, but I don't see why, because for instance, you're saying it's a competitive advantage, but if the competitive advantage gets me the contract and my customer doesn't, that's not a short-term benefit. That's basically what makes the whole thing possible.
Because it could be long-term if it leads the company surviving.
Yes.
But what if you don't refactor and then the quality of the product is degrading, and in the long term, that customer goes away if you can't implement new features?
Right, but thinking of the decision model, what the development organization has to make a decision on, surely they would be considering this as having really long-term benefits.
In terms of customer retention.
or in terms of survivability, as Jonathan says. I mean, this
Is
is
this an issue of scope, like whether you're looking at just the technical product side versus if you're looking at business considerations?
Yeah, I would say, so now this is like bridging the gap between the people in the technical organization, I would say. So technical people and the non-technical people in the technical organization still. But
if you're not looking at the business considerations, why would you ever decide to incur technical debt? I mean, what Cunningham's original proposition was
Yes,
they were doing
yes.
it for business reasons, right?
yes, that's a good point.
And what's more, you're doing it with intent, with, you know, with happiness. Oh, look, we can take a shortcut so we get the job.
Yes, so using TV as a strategy, yes. But I think this is a problem with the terminology, probably short-term versus long-term.
Yeah, I think maybe it would be hard to call it maybe taking on risk. It's like a risky decision. I mean, maybe short-term is the wrong word. It's like an immediate benefit that is associated with long-term risk, right? Because that's what the debt is. That's anything like
Right.
at some point the debt has to be paid back, right?
Yeah.
I mean, that's the whole point, right?
Well, but in the meantime, I mean, for instance, so I don't want to be mean about this because you started off with the joke of the picture of the house.
Yeah.
Right? Why is the house falling apart?
Because its quality is not good.
But that's not what technical debt is about. Right? I would suggest that a better example would be a house that had been built with no windows in order to be finished more quickly. And therefore people could live in the house. But it wouldn't be very nice because there was no windows, but at least they would have a house and they could be added later. I mean, isn't that the way it would really? I mean, I guess my point is this. In real life, we willingly take on debt all of the time. For instance, if one is buying a house, and one isn't a billionaire, right? One will make the informed decision, right, to go into debt because in the short term, or rather in the immediate term and long lasting, you have a place to live. And so this is a kind of informed decision. It's not an error. It's not a mistake. It's something that you decided to do because you decided the advantages outweighed the disadvantages. And I guess that's one thing I'm not hearing when you talk about the model.
Well, TD can be introduced knowingly or unknowingly. I mean, it
What's
could be
an example of it?
intentional or unintentional. So if there are noise developers, they might introduce TD unintentionally.
So are you certain that that's compliant with what Cunningham was talking about? Because that just sounds like bugs. That sounds just like sloppy work. I don't see why we have to count that as technical debt.
Yes, I agree with you that defects cannot be considered as technical debt. But I think Cunningham's first definition was not quite right code. Doesn't mean that it's really bugs.
I mean, one example, I don't know how much you agree with this, but technical debt with the house eventually falling apart is just using parts that are not really useful in the long term, right? So say Facebook was originally built around MySQL database. And with a single instance that only works so long until your user base kind of like grows larger and larger. Right. And the fix then was kind of to have like loads and loads of MySQL databases somehow, like working with each other. And that's not a very stable system. And like needs constant like maintenance and all that stuff. But it's kind of like, you built your house and you couldn't really afford to make everything like super stable, so you bought like the cheapest components and they might just break at some point after a relatively short time of use.
Right, but that seems totally sensible to me.
Oh yeah, it's totally sensible, but it is kind of like this is mostly in defense of the picture of the house that is kind of falling apart. Because as you put more stress on this thing, in the long term, it will eventually.
Yeah, I know, but that's true. That's true of every house that's ever been built.
Every software that people check that.
So actually, so I'd like to ask a question about a later section of your talk. I want to probe a little bit what you mean when you say assess. Because you have a model, and I see the model is, a pretty comprehensive model of technical debt. And you talk about how you then assess prior work according to the model. To me, it feels like you're doing a comparison, not an assessment. And maybe I'm not seeing the depth of which you're doing it, but it seems like you're saying, well, these approaches, consider these factors and they maybe apply to this problem, but you're not saying how good they are. Right? How much does it actually help me, as a manager dealing with technical debt? Have you answered that question with your model? Can you answer that question?
I think it's actually pretty difficult to give a fair assessment in that case because, so that's why I'm saying here that it's that
It's more like
TD
coverage.
comprehension of TD quantification. Like if this, so this is coverage, and then the decision model, let's say, determine if these approaches help you make those decisions. But let me go into that. Yeah, so these kind of assessments can be done, but still there are problems with evaluating these approaches in terms of technicality. So some of these approaches might run on one set of platforms and the others might run on another set of platforms. They might use different programming languages and different, so when you take the TD item itself, so the software artifacts that are being mapped to it is like code smells, design smells, or architectural smells. So then the definitions for those also can be different for different tools currently. So it's not a fair assessment if I try to do that level of assessment.
Yeah,
So,
I guess I see that, but it feels to me like you're sort of counting boxes and checklists. And what I really want to know is, something that could be answered by a case study or an experiment or something, right? Which is more like, in a real world situation, I've got technical debt. How much does this approach help me, actually give a decision, right? So I mean,
yeah. So
I don't know exactly
current,
how to design this, but when I hear the word assessment, I think in those terms, and not in the terms of kind of checking what this approach is conceptually capable of doing versus this other approach. I want to know concretely, is it useful?
Okay.
Does it help me as a manager? So anyway, I mean, it sounds maybe like you might get more into that with some of your future work, which would be really exciting. In terms of your, the work you've done, I think that's also, I mean, there's definitely a role for this, and like understanding the relationship between these. I'm just not sure I would sell it as assessing. I might sell it as comparing or, understanding these models.
Okay.
Assessment seems like maybe overselling, or selling it as something that it's not.
Okay. So it's like
it could, right? Because you could cost these things, right?
Yeah.
And in a real world development, you would cost them in time or dollars or something like that. And then you really could be assessing.
Right, yeah.
So to answer that, yes, with the calculation model, if you, so this is like a very simplified model. So I'm making the assumptions, like for example, that I incur only one technical debt item during a development step. So by changing these variables and assigning values to this, you can also utilize this for decision making.
One thing that would be really interesting with this model is to actually put in some plausible numbers. And you could do it.
Yeah.
Just on the basis of reasonable time. Obviously, a case study is going to be better, and then it could be informed.
Yeah,
But for all of the things in there, you could at least put in numbers of hours or days or weeks or that sort of thing. Because some of the numbers that you're adding up could
Yeah.
well be wildly bigger or smaller than the
Yeah,
others.
yeah.
And then you might really get some sort of understanding of the shape of the arithmetic involved.
Yeah, I kind of did. I did try to write a paper based on that, but like, I think people are mostly interested about the assumptions in that case, and like questioning the assumptions rather than trying to see what can be doable with this. So I would like to hear your thoughts, like how I could improve on that.
Yeah, sorry if I have cut this a little short. Because,
Oh, sorry.
we're already with time. You know, feel free to find each other at the conference.
Yeah, but don't take my criticism, especially because I really like going through all of this. And for all of the papers that I've read about technical debt, this is the most systematic approach, and that's why I like it so much and I want it to succeed.
Thank you so much.
yeah, so it's a big problem, not hard problem.
Thank you, Jim.
Thank you.